Here's a question on geometric sequences, okay? And this might be something that you could encounter while preparing for the IB if you're taking the high-level maths exam, okay? And if you'd like to see anything similar to this, or if you have any suggestions for any content that you'd like to see on the channel, let me know in the comments. So this question is more of a proof in a way. So it's asking to show that if this sequence an is a geometric sequence, then the nth root of a1 times a2 all the way to an is equal to the square root of just a2 times an minus 1, right? Now, this is another way of saying that the geometric mean of the first n terms, right, is equal to the geometric mean of the second term and the penultimate term. So, yeah, we have two terms here, and essentially this is a 2 here, but that's a bit redundant. So yeah, that's what we have to show. We have to show that if this is a geometric sequence, then the geometric mean of the first n terms is equal to the geometric mean of the second and the penultimate term. Okay? So the way to do this would just be to write down how the geometric series, or how the geometric sequence works in general. Okay, so we have the first term equals the first term, and then we have the second term, which is equal to the first term multiplied with a constant number, right? A ratio or a quotient, or however you want to call it. And then each or every other term, you can obtain it from the first term, and then you multiply another q. So this is going to be times q squared. And then the fourth term is going to be a1 times q cubed, and so on. So an in that case would just be a1 times q to the n minus 1. Okay, so what we'll then do is we'll take all this stuff and we're just gonna put it under this square root here, or under this nth root rather. So let's see what we have. We have the nth root of a1 times, and instead of a2, I'm just gonna write everything in terms of a1 and this ratio, this q. Okay, so we have times a1q and then a1q squared all the way up to a1q to the power n minus 1. Okay, so this therefore becomes, now we have n terms and a1 appears once in every term, which means we have n a1s. So a1 is multiplied with itself n times, which means that this is going to be a1 to the power n. And then we're going to have q times q squared times q cubed all the way up to q to the n minus 1. Okay? So first of all, a1 just comes out. Okay? So it's a1 to the power n, and then you take the nth root of that, which is just a1. And then this is the nth root of q. And now instead of writing it like this, we're just going to add the powers up. So this is going to be 1 plus 2 plus all the way up to n minus 1, which is a1 multiplied by the nth root of q. And now this sum, we know it from the arithmetic sequence that this is just n times n minus 1 over 2, like this. So this is a1 times, and we can rewrite this as q times, or q to the power n times n minus 1 over 2. And being, well, having an nth root here is the same as dividing this power by n, right? So that means that the n's cancel out. So the final result that we get is a1 times q to the power n minus 1 over 2. So that's the closed form of this product here, of this geometric mean. Okay, so now we have to treat this separately, and if whatever comes out of this is equal to uh, what we have here, then the question is considered to be answered. Okay, so this is a bit simpler to deal with, right? So that's just the square root or the geometric mean of two terms. So we just have a2 times an minus 1, which is a1q, right? That's the second term. And then the other term is a1 multiplied by q to the power n minus 2. Okay, so this is the square root of a1 squared times q, and this is going to be essentially q to the power 1 times q to the power n minus 2, which is just q to the power n minus 1, right? We add up the powers, there's nothing new here. And then we can take the a1 in front, and this is just q to the power n minus 1 over 2. Okay, so this is what the geometric mean of the last and the penultimate terms is, and this is what the geometric mean of the first n terms is. And as you can see, they are the same. So that's how you do this, and that's the end of the question.